Let us discuss the exam solution. I'll discuss them one by one. So in problem 1, these are actually short questions. You have to just apply a simple strategy and then find the solution. The problem 1 is that find Vx in the network using Talighan's theorem. This actually implies that we have to use this theorem, which is actually sum of all powers should end up into 0. So it means that we have to find the power in each element, and then we have to sum them, and one of the voltage is unknown, so that can be found from this theorem here. But at the same time, I can counter check my problem just by using KVL. So whenever we use KVL, so we have to think of a loop. So I have considered a loop usually clockwise, and the assumption by considering this is that the positive charge flowing in this clockwise direction. So if I can start KVL from any point, so it doesn't matter which starting point you take. So I'll take the starting point from this from here, and I assume positive charge is flowing coming from here. And as the first I'll discuss the logic. The logic is that if positive charge is flowing, positive the polarity terminal, this positive says that this is high potential and this negative says it's low potential. So if positive charge flows from high to low potential, so it will lose energy, and at the same time the power will be consumed, or power will be the electrical energy would change into any other, maybe a heat energy, or maybe whatever the case is, whatever this element is. So let's take this one. If the positive charge which is flowing from here is also flowing through these elements, and then when it reaches here, so at this point the positive charge is flowing from low to high. So whenever it flows from low to high, it's gaining energy, or so to speak, with respect to power, this is actually power is being delivered by this element here. So I'll just so that was actually the logic, and now I'll discuss the shortcut method. The shortcut method is that if you see this positive charge, if hits this positive terminal, I'll write positive here. So that means that we have to know the polarity of the element. If we don't know the polarity of the element, we cannot write the KVL. So we have to assume. It doesn't matter. For example, if this Vx, we don't know what is the voltage across this element 2 is, so we can arbitrarily assume this is positive, this is negative. The other choice would be this is negative and this is positive, so it doesn't matter, and you'll just assign a variable. So if you hit a positive terminal of the polarity, then that will come here. If you hit a positive terminal, that will come here. Negative terminal, that negative comes here. Regardless the value of the regardless the sign of this voltage here, this can be minus, this can be plus. So whichever the sign is here, you will just copy as it is over here. So this was plus 9, I copy plus 9 over here. So plus Vx, so this is a positive, the charge is coming and hitting a positive terminal, so I'll write positive. In this element 3, the entering terminal is positive, so then you'll write plus here. This entering terminal or hitting terminal is negative, so I'll write negative here. Some people use the leaving current, so it doesn't matter, so the equation will remain same. If you shuffle the equation to the right hand side, both equations would be same. So now I'll do just one again very quickly. KVL in this loop is I have assumed the direction. Positive charge I know is flowing in this direction, so I'll just come to this one. I hit a positive terminal plus, and this was a plus 9, so I write plus 9. Plus 12 volts, plus 12. Minus 24, minus 24. Plus Vx. Plus a plus, and this is 16. Minus, and this is minus 12, is equal to 0. So if there is one equation and one unknown, so if I solve this, Vx is equal to minus 1. But now this was just to counter check to know what is Vx, so I'll just now use the Taligan's theorem. I have to find the power across each element. So I'll start from this 9 volt here. It doesn't matter from where you start, I'll just use them one by one. The logic for the power is that if it is a passive element, which is passive element is that element in which if the charge is flowing, I'll use the book notation. The book notation is like this: if there is some element and if positive charge is flowing, if this I is positive, it means that the positive charge is flowing from in this direction, from this upper direction here. And if it positive charge is flowing and this is a passive element, so passive element, the positive charge will flow from high to low and it will lose energy, similar to the gravitational potential, that if you are at a height or a high altitude and if you go towards a low altitude, then you will lose the potential energy. Similar is the case if a passive element, positive current is flowing, positive charge is flowing, then it should flow from high potential to low potential, and it should dissipate power or it should lose energy. So for dissipation of the power, so P is actually positive, and for the other case, which is delivering power, this power should be negative. So if power is positive, I know certainly that this element, that element would be consuming power, and if the power is negative, I would know that that element is delivering power or giving power. So power in 9 volt is I have to know the voltage and current. So the current, because this loop is a single loop, so current is given 2 ampere, so it means that 2 coulombs per second is flowing in clockwise direction. So in this case, I will see that if the current is hitting a positive terminal, so the power is positive. So I'll write positive sign. I haven't mentioned here, but you should write positive sign for that particular case. And this multiply 9 into 2 is actually 18 volts. If you go towards the element 1 or 12 volt, power across 12 volt element, so that would be the voltage into current. So this is plus 2 into 12, which is 24 watts. So this is absorbed, this is absorbed. Now let's see this element. If the current is hitting a negative terminal, just write negative, because it is not hitting a passive the positive sign here, then this is negative. Just multiply simply 2 into 24. So 2 into 24 is minus 48. This minus sign tells me that this element, this voltage source here, is giving power or delivering power. Power across this unknown voltage Vx should be, the current is hitting the positive terminal, so this is plus, and the current is 2, so this is 2, and voltage is Vx, so 2Vx. Power across 16 volt or third element, so I've written here P3 subscript 3 is equal to, current is 2 ampere and it is hitting a positive terminal, so plus 2 into 16, which is plus 32 watt. Power in the 12 volt source, so it is hitting a negative terminal, so I have written here negative, and just multiply 2 by 12, which is voltage into current, this is power, and this is minus 24 volt. So I can see here that only this 24 volt source and the 12 volt source are delivering power, whereas in this case the 9 volt source, its power is actually positive, which means we can assume that we can infer that this element is this voltage source is being charged. So I sum up all the powers. So this is 18, 24, minus 48, plus 2Vx, plus 32, minus 24. This is one equation and one unknown. So 2Vx plus 2 is equal to 0. This ends up into this one, and Vx is equal to minus 1 volt.